My name is Dheeraj Khurana and this is my application MavericKart. My application is a decentralized online marketplace which is based on Ethereum blockchain. So this application connects buyers and sellers directly without the need of a middleman. Its working model is very different than a normal conventional marketplace, which is centralized. Normal marketplace like Amazon, eBay needs a central authority, like the organization that intermediates the transaction between buyers and sellers, whereas MavericKart is totally decentralized. So let's get started. Before I get into my application, let me tell you about the architecture and what you're seeing right now. So my application, which you just saw right now, that was the front end. And this web front end is connected to the blockchain and the IPFS server. This IPFS server is the interplanetary file system, which is a peer-to-peer file sharing protocol. This IPFS server is needed to store image description and image photo inside the blockchain because blockchain itself cannot store high Mbps, kbps image files or description files. Another thing which is really important after web frontend, IPFS, and blockchain is the backend, which is Node.js. This Node.js has an event listening function which listens to every instruction that is noted down on the blockchain and stores the product information into the MongoDB. This portion of the application, which is MongoDB and Node.js, is an off-chain solution, which I will talk about later. Let's go back to the application. So here you can see the main page of my application. You can see my public address, which is written. So to start with the application, the important thing you need to note is that you have to be connected to an extension called MetaMask. MetaMask is a blockchain extension which helps you connect to the Ethereum network. So right now I'm on the Ethereum testing network and you can see I'm using the seller account. So we have two accounts right now, seller account and buyer account. Seller account has 99.83 ethers and buyer account has 100 ethers initially. So let's use the seller account which has 99.83 ethers and list a new product to the marketplace. Okay, so I'm adding a new product right now. So this is the product addition function. So let me write a new product. So let's take it as Samsung Galaxy phone. I'll make a category. So this comes under cell phones and accessories. Let me upload a new picture. This picture is the product picture. So I uploaded a picture. Let me tell about the phone. This is the product description. So this is a Samsung phone and it is blue in color. Let me put a price on it. So I'm putting 0.5 ethers and let's put a product condition should be new and I'll put today's date to register my product and the time. So start time basically means the starting of the product listing time. So I'll add this product to the blockchain. So yeah, you can see a MetaMask notification just popped up. So let's see. So I'm making a transaction from the seller account to the blockchain and this is the smart contract address. You can see it's not charging me initially anything, but then it's taking some ethers to register on the blockchain. This registering fees is also known as gas fees, which allows me to list a product on the blockchain. So let me confirm that. So it deducted 0.0094 ethers from my account. And now let's see what happened actually. So I have the blockchain open right now and you can see a transaction was made and you can see the transaction hash, gas usage, block number 23. So this is the blockchain transaction that was recorded into the blockchain. So when it was recorded onto the blockchain, you can see the Node.js has a listening event. So now I'll show you what actually happens on the Node.js. So let's go to the Node.js console and you can see this product number 21 and Samsung Galaxy like I added just a minute ago. And you can see the category, One important thing to note is we have image link as a hash and we have description link also as a hash. These two hashes were given out by the IPFS server, which stores product image and description and gives out a hash value which can be stored onto the blockchain. And this blockchain information was then retrieved onto the Node.js console. So this is the entire product. And as I showed you before, that Node.js, this puts the product information into the MongoDB. So let's go check our MongoDB. This is a MongoDB database. So let's see if the product was actually added. So you can see the Samsung Galaxy phone was added. You can see the name here, Samsung Galaxy, and the product ID. And you can see two hashes here, which is for image and image description. So let's go back to our homepage where we added this product. So let's see if the product actually got added into the front end. So all this front end you can see here is getting rendered from the MongoDB. Oh, you can see there's a price 0.5 ethers, and this is the product. As you remember, we added Samsung Galaxy phone. So let's try to buy this. So to buying this product, let me change my account and make it a public buyer account. So I'm moving an account and I'm going to the buyer's account. So now I have the buyer's account which has 100 ethers in it. Okay, so let me buy this. So I will try to buy the product right now. As you can see, this is the same description and the price we entered a minutes ago. And you can see the public address of the buyer. You can also cross-check the public address of the buyer, which is rendered onto the front end. Here, you can see it's 0x9943 ending with 9f, and the similar public address has been written here. So that's how we know we're using the buyer's address. Let's go down and let's go buy the product. So I'm buying the product right now. That's where you see the MetaMask notification. So you see I'm making a transaction from buyer's account to a smart contract, and the product itself is 0.5 ethers, but I need to pay gas fees to register it onto the blockchain. So I'm paying 0.00, I'm paying 0.027 ethers to put it on the blockchain. So let's confirm this and let's put this on the blockchain. So I'm transferring my money from buyer's account to smart contract. So this important thing to note here is the money isn't going directly from buyer to seller. The money is kept into the smart contract with this public address, and the money will stay there until and unless the conditions are fulfilled, which I will talk about later. Let's confirm this, and the instruction was listed onto the blockchain. So you can see the instruction was made with block number 24. It says we have successfully purchased the product. So let's go back to the home screen and let's actually go to the My Orders section and let's see if the product is actually there. So I click on My Orders and you can see the product we purchased is in the order history. Let's look more into it. Okay, so as you can see, my public address is there, which is my buyer's address. And this part is a really important factor in the working of our platform. So you can see the buyer's address, which is my address right now because I have the buyer's account open. You can see the seller's address, and this is arbiter's address. So to have a complete transaction, buyer and seller need to both agree that the buyer has received the product and seller has sent the product. So if I'm a buyer, and in an ideal situation, what happens is buyer gets the product and buyer will say, I have received my product. So I want to release my funds that was sent to the smart contract to the seller. So I'll release funds to the seller using this button. So this functionality is called the escrow functionality, which is implemented using the escrow smart contract. So I'm releasing my funds to the seller. So I'm clicking on it and I'm making a transaction which is getting registered on the blockchain. So you can see it's charging me some gas fees. Let's confirm this. And now, as we confirm this, you can see there's a vote that was registered. So the vote says escrow vote count for releasing amount to seller is 1. So buyer agrees that I have received my product. So similarly, now I'll change the MetaMask account to the seller account. And in an ideal situation, I'm gonna refresh the page now because I just changed account to seller account. So I want that to register. So in an ideal situation, buyer and seller both agree. So in using the seller account, I'm gonna agree that I actually sent the product. And buyer also said that they have received the product. So I'll say release funds to seller. So give me my money for the product I provided. So I'll say funds released to seller, and you can see another MetaMask notification popped up. So there's a transaction happening from seller to the smart contract. This is the escrow smart contract, and different than the normal smart contract, which allows us to list the product. So I'm paying a gas fees to tell blockchain that I did send the product. So in this ideal situation, what happened was buyer and seller both agreed that they have a buyer has received the product and seller has sent the product. So after the second vote, when both people agree that they have done what they were supposed to do, then the money was released to the seller from the escrow. So you can see a transaction was made, and now the funds in the seller account is more. If you remember, the initial amount in the seller account was less than 100 ethereums, but after this new transaction it's over 103 ethereums. So the money was sent from escrow account to the seller's account. So that's why it has more than 100 ethereums right now. Let's go back to the homepage. Another important thing that I'm going to explain right now is the use of MongoDB and Node.js. So MongoDB and Node.js constitutes of the off-chain solution. So why do we need MongoDB and Node.js? We need MongoDB and Node.js to render products on the front end and to apply filtering logic. So suppose I want to filter all the products by one category. So suppose I want all the phones to display because I am interested in buying a phone. So if I want to buy a phone, I will filter it. But if I put the filtering logic in a blockchain, and to put the filtering logic to a blockchain, to put it in a smart contract, I will have to put the logic in the smart contract, and that will increase the number of lines in the smart contract. So what does that mean? Increasing the number of lines in the smart contract means you will have to pay for more gas fees because number of lines is directly proportional to the gas fees a user pays. To avoid that, we instead of putting the logic of MongoDB inside blockchain, we put this up aside in a separate Node.js console, connecting to a separate Node.js console. Another key reason of putting MongoDB separately and not putting the filtering logic into the blockchain was whenever you have to update the filtering logic. So suppose I want to change and I have to change the filtering logic and I want to add another category and I want to add like a furniture category. So I want to list down all the products using a category called furniture or electronics. To edit my filtering logic, I will have to redeploy my smart contracts and change my smart contracts, which creates a lot of hassle because you are redeploying your application again. That's the reason why I included MongoDB and Node.js separately, and this is a very important part of the application, which is an off-chain solution. So let's go back to the homepage, and going back to the product we purchased. Another important thing I need to tell you is about the arbiter's address. So arbiter comes into place whenever there is a disagreement between buyer and seller. So we have three cases where there's a disagreement between buyer and seller. When buyer lies and he says I haven't received the product, when seller lies and he says I haven't I sent the product but buyer is lying whereas he hasn't. And third case, when a seller sends a damaged product and buyer needs to return the product. So in that case, arbiter is the one that decides. Arbiter can either decide with buyer and say funds released to seller. Arbiter can also decide with buyer and say the buyer is right and seller hasn't sent the product, or he has sent a faulty product. So we can also do funds return to buyer. So to become an also an important part of this application is to become an arbiter you have to pay 5 ethereum deposit, and that makes the application more secure to any fraudery. Yes. Now, and apart from the arbiter's logic, another key factor is when arbiter lies. So to secure buyers and sellers from that, buyer and seller can also reappeal arbiter's decision to release fund to seller or to return it to buyer. And to reappeal the arbiter's address, this arbiter was chosen randomly. So in this case, another arbiter can be chosen randomly and he can decide if the original arbiter was right or wrong. So let's go back to homepage. And the upside part of it, you can see Ethereum API is running, which shows the latest price, which refreshes every 20 minutes and updates the end user of the Ethereum price while he's making transactions. So that's about it. That's my application MavericKart. Thank you so much for listening.